Hello all. Previously we have completed the doubly linked list insert and delete operations. Now in this particular video we will see what is circular linked list and how it is different from singly linked list and doubly linked list, and in general what are the types of circular linked list are available. So let's get started. All these details I will complete in this video. So what is circular linked list? Is a variation of linked list where last node points back to the first node so that it will form a circle. So that's how the name circular linked list comes into picture. So unlike other linked list, or if you can consider linear linked list like linked list or singly linked list or doubly linked list, where last node address is null only. If you consider linked list, singly linked list, the last node address is null, and if you can consider doubly linked list, the last node address is also null, and the first node previous part is also null in doubly linked list. Now in this case, that won't be the case because it should form a circle. Okay, so there are two types of circular linked list are available. One is circular singly linked list and another one is circular doubly linked list. And as you can see in this diagram, we have three nodes. One is 100, 200 and 300, and I have forgot to mention the address here. Let us assume that the third node address is 300, and the last node address part should have the first node address, so that last node and first node will be interconnected, right? So that forms a circular structure. And when it comes to circular doubly linked list, in single linked list, only the forward direction traversing can be possible, but in doubly linked list, forward and backward traversing also possible. This is a bidirectional traversing. Okay, so to facilitate that condition, in circular doubly linked list, we have to follow very carefully this step. The first node previous part should be the last node address. First node previous part, the last node address part will be assigned in first node previous part, so that the first node and last node will be interconnected. In similar fashion, the last node next part will have the first node address, so that the last node and first node will be interconnected, so that the bidirectional traversing can be happened. Okay, so that's how the circular doubly linked list traversing can work. Now let us see the operations in circular singly linked list. I will begin with how to insert a node at the beginning of circular singly linked list. So let's get started. This is the algorithm. First, create a new node and assign a value, and check if the head is null. For this purpose, I will take two global pointers. One is head, another one is style. Both are initially points to null only. So first of all, create a node and assign a value. Check if head is null. So if head is null, then whatever you have created in the node, that will become the first node and last node itself. For that node, so you can, whatever the temp next value, whatever the new node external value, that will points to itself, right? Because even though if we have a single node, that will possess the circular linked list property, that should possess. Otherwise, how can you consider that it is a circular linked list? For this purpose, set the new node's next points to itself. So whatever that address will be assigned in temp next part, so that the circular structure will be maintained for that node itself. Okay, then initially head and tail will be null, right? So now head and tail should points to this particular new node. Okay, so head and tail will be points to this particular new node. So instead of going through theory, I will take an example. I will show you how this algorithms behaves. Now let us say, this is the code by the way. Now let us say we don't have any linked list, and assume I have called insert at beginning function with 30 as parameter Now step 1, create a node and assign a value. So I have created temporary node, and this temporary node is a new node, by the way, and 30 is assigned in the data part, and the address is 100. Okay. Now check if the list is empty by using head double equal to null. So head is null, right? So in that case, first step, whatever the temp next value, initially this is empty, whatever the temp next value, assign with the temp value only, so that it points to itself. So what is the temp value? 100. 100 will be placed here, so that it forms a circular linked list property. Okay. Now head and tail initially null, right? Now head and tail both should be point to this newly created node. So how do we do that? Head is equal to tail is equal to temp, or tail is equal to head is equal to temp, whatever you have considered, you have follow. Okay. So what is the temporary address? 100. So 100 will be assigned in temp, 100 will be assigned in tail, and that tail address will be assigned in head. So this is the right to left associativity. Okay. So that's why head and tail both will be pointing to the whatever you have created, that is the first node. Okay. Now we assume there is a node in circular singly linked list. So as you can say, this is the new node. Now I am trying to add another node at the beginning by using a inserted beginning function with a parameter 20. Assume this function call is happened. Now create a node, assign a value. So the first step will completed for this. Now check if the list is empty, but in this case the list is not empty, so else part will get executed. In else part we have three statements. First of all, these two nodes should be interconnected. That is the first step, you have to be careful. First temp next will be assigned with head value. What is the head value? 100. 100 will comes here, so that this temp node and head node will be interconnected. So this is the updated diagram for after first step. And when it comes to second step, now we have to somehow form the circular structure in order to maintain circular linked list property. So for that purpose, whatever the tile next value should be assigned with the temporary address value. So whatever the tile next, previously it is 100, so that will be replaced with temporary address value. So what is the temporary address value is 200. Now 200 will be here, so that we forms the circular structure. And then when it comes to the you have to be careful with head and tail. Since it is a beginning, since it is a inserted beginning function, we have to worry about only head pointer. So whatever the temp node value, that will be assigned in head node. So head node will automatically points to first node itself. So this is how the updated circular singly linked list diagrams look like. Okay. Now similarly, I have called inserted beginning with 10 as a parameter. Now this is the updated circular singly linked list. Okay. So now try to see the code so that you will understand. So whatever we have performed, that is this code. If there are some nodes, first of all, create the link between first node, whatever you have created that node, right? That will be the first node, because obviously this is a inserted beginning function. So that node and whatever the previous node, that should be interconnected. What is the previous node? Previous node, obviously the previous first node, right? That should be interconnected. So temp next is equal to head, so that the new node and the previous linked list will be interconnected. Now next we have to form the circular linked list property by using a statement called tile next. Tile next will be the initially it will be some address. Now it should be assigned with the new node address, so that we forms the circle. And then initially head is at some other location. Now head should be moved to the new node address, so that head will points to the first node. That is the logic here. Now let us try to traverse this code. Let us try to display the elements. So if head double equal to null, we don't have any nodes in the linked list, so nothing to do in this case. And assume there are some nodes. Now we create a temporary pointer points to head and traverse this temporary pointer. So how do we do that? Printf do while loop. For this purpose, if you consider the previous linked list, let us say circular linked list, consider the previous linked list in the sense singly linked list and doubly linked list. In that case, we have the null values. So as soon as null values, so whatever the values present before null, those will get printed, those will get displayed. That is the condition we try to follow in order to traverse the linked list. But in this case, null values are not there. So how do we know that is the end of circular linked list? So by using a condition called if temp is equal to head, that means we have reached the end of circular linked list, then we can come out of the loop. So in that condition, with that condition we can traverse the circular linked list. So first of all, do %d temporary data. Assume the temp is present at the first node. What is the temp data? 10 will get printed. Now temp will move to the next part. Now temp is at here, temp is at the second location. Now check, is 200 not equal to head? Is 200 not equal to 100 or 200 not equal to 300? Yes, condition true. Again do while, go to the next iteration. Now temp data, now temp is at the second position, right? Temp data is 20 will get printed. Now temp will move to the 100th part. So is 100 not equal to 300? Correct, right? Now again do while loop moves to the next iteration. Temp data, now 30 will get printed. Now temp next is 300. Now temp will move back to the head only. Okay, temp moves back to the head only. Now is temp not equal to head? Is 100 not equal to 100? The condition false, and we have come out of the loop. And we will write one statement. Back to head means it is a circular linked list, or back to head, or normally people will write head only. So whatever you have comfortable, write that statement so that we'll let them know it is a circular linked list. Okay, so that is how we can traverse. Now I will execute this code. This is the inserted beginning function, and this is the display list, that means the traversing part. And as you can see in that example, I am trying to add 30, 20, 10, and I am displaying the list. So let us execute and compile and run. You can see 10, 20, 30 and back to head. That means it forms a circular linked list. So that's it for this video. I will see you in my next video. Thank you.